Hello everyone, myself Sriram Siddharth from BTech CSE regular JNTH and my professor is G. Raju. So today I'm going to tell about superposition theorem and let's see some problems on superposition theorem. First of all, what is a superposition theorem? So the superposition theorem states that in any linear and bilateral network or circuit having multiple independent sources, response of an element will be equal to the algebraic sum of the response of that element by considering one source at a time. So basically, the response of an element will be equal to the algebraic sum of the responses of that element by considering one source at a time. So by short circuiting or using open terminals, we can find the the response of an element. So that's a superposition theorem. So let's see some steps how to apply superposition theorem. So there are four steps to apply superposition theorem. First step, you need to turn off all sources except one. That can be voltage or current. If that it is according to the question, you need to apply the uh, source, turn off the source. So with the help of open circuits. And next step is like you need to solve the circuit for the active source. Uh, that you need to solve the circuit which you'll be like keeping active, so you need to solve that circuit. And the third step is you need to repeat the same process for the other source, like which will be you'll be closing, right, or short circuiting. Like for that circuit you need to repeat the same process, and later you need to add the individual contribution algebraically. You need to add the currents which will be getting individually, you'll be getting some currents, right? You need to add those currents. So let's see some questions. Let's see some problems on superposition will be easy to understand. So let's see some problems on superposition theorem. So here's the first question. We need to find the current source through 20 ohms using the superposition theorem. You need to find the current source. This is the circuit diagram. You need to find the current source through 20 ohms resistor. So first of all, let's consider 20 volts voltage, and we'll be open circuiting the remaining current sources. So let's first take 20 volts voltage, and by applying the nodal voltage V1 for determining the nodal voltage V1, we will be using a nodal analysis method. So the nodal equation at node 1 will be getting like V1 minus 20 by 5 by plus V1 by 10 plus V1 by 10 plus 20. By solving this, we'll be getting V1 as 12 volts, and the current flowing through 20 ohm resistor can be found using the following equations. So we need to find I1 current. So like by finding I1 current, we'll be using I1 equal to V by 10 plus 20. We'll be getting I1 current, which is 0.4 ampere. So the current flowing through the 20 ohm resistor due to 20 volts voltage is 0.4 ampere. So in the third step will be we need 20 ohm resistor considering. Also we'll be using the 4 ampere current source, and we'll be short circuiting the 20 volts voltage. Here we'll be considering the 4 ampere circuit, and the other circuit which is 20 volts will be short circuiting it. So here if you can clearly see, the 5 ohms and 10 ohms resistance are parallel to each other. As they are parallel to each other, will be equivalent resistance will be finding, which is like we'll be getting like 40 by 3 ohms here. Like if you find the equivalent resistance, as they are 5 ohms and 10 ohms are in parallel to each other, we'll be getting equivalent resistance 40 by 3. So this is the simplified circuit. So this is the simplified circuit, you can clearly see. So here we'll be finding a second current through 20 ohm resistors by using current division principle. So we'll be getting I2. We know the values we got, R1 we got and R2 we got. So by substituting those, we'll be getting I2 current, which is 1.6 ampere. And now we got I1 current, which is 0.4 ampere, and I2 current is 1.6 ampere. So here R1 is 40 by 3 and R2 is 20 for clear information. So basically, so summation of I1 and I2 will be giving the current through 20 ohm resistor. So which is I1 we got as 0.4, I2 as 1.6, total is 2 amperes. So basically we are getting here the current through 20 ohm resistor is 2 ampere. So from superposition theorem, we can find the current through 20 ohm resistor, which is 2 amperes. We got this, and this question answer. So 2 2 ampere is the answer. So we'll be seeing the next question here. So this is the next question. We need to find the 3 ohm resistor using superposition theorem in the circuit. So we need to find the current passing through the 3 ohm resistor. And first of all, let's consider 20 volts voltage to find I1 current. I'm using 20 volts voltage, and other one I'm short circuiting it. Other voltage circuit I'm short circuiting this the current after short. This is the open circuit after short circuiting it. So we need to determine the total current here over here. So to find the current through 3 ohm resistor, we need to find the total current I1 and I2. So we'll be getting, so let's first of all, let's find the total current. We can clearly see here as 3 ohms and 6 ohms are parallel to, sorry, 6 ohms has not be printed. So 3 ohms and 6 ohms are parallel to each other. So we'll be getting equivalent current as 7 ohms. So we'll getting equivalent current as 7 ohms. So with that, we'll be finding the total current. Total current is V by equivalent current, which is 20 by 20 by R equivalent, which is 7. We'll be getting 2.857. So now the current I1, which we will be getting as uh, total current into the parallel current, which is like we'll be getting 2.857 into 0.667. You can see the calculations. Y1 will be getting as 1.904, and next 1.904, and in the step 2 we'll be finding I2. So let's take 40 volts voltage and we'll be short circuiting the 20 volts. So by short circuiting the 20 volts, we need to take with the help of uh, 40 volts. So you can clearly see here like 3 ohms and 5 ohms are parallel to each other. So let's find R equivalent. We'll be getting at 7.875 ohms. By applying Ohm's law, we'll be getting total current, which is 5.079. By using current division method, we can easily find the current through 3 ohms resistor, which is I2 will be getting as 3.174, which with the help of total current, we'll be getting I2 current as 3.174. So we got I1 and I2. Uh, we uh, we got I1 and I2. Now we'll be finding that with the help of that I1 and 2 by superposition theorem, total current is determined by adding the individual currents produced by 20 volts and 40 volts. We got the individual currents by with the help of superposition theorem, 20 volts and 40 volts. Currents I1 we got as 1.904 and I2 we got as 3.174. The total will be getting as 5.078, which is the current through 3 ohm resistor. The current passing through the 3 ohm resistor is 5.078 ampere. That's the final answer. You can see if you want. And let's move on to the next question. This is the third question. We need to find current IL passing through 8 ohms resistor in the given network. So this is the circuit diagram. We need to find the current passing through the 8 ohm resistor. So first of all, first we all know that we need to take 28 volts voltage, and we need to we will be open circuiting the terminals the other side, like the other voltage will be open circuiting terminals. So we got 28 volts, and with the help of that, we'll be finding with the help of KVL, we'll be doing this. So basically, due to open circuit, we'll not be having any current passing through the 10 ohm resistor side. So we'll be only having the current through 28 volts side, through 6 ohms and 8 ohms side. So by applying KVL loop to the loop, we'll be getting IL1 as 2 amperes. So you need to calculate that 6. So by we got IL1 as 2 amperes. So now we need to repeat the same procedure for the other current sources. Remove the voltage source by short circuiting it, and we'll get a 28 amperes. So will be remaining. So by short circuiting, we'll be getting two loops. I1 and we'll be getting your I1 and I2. Two loops will be we need to calculate. So to find the current through IL2, we need to do the loops for I1 and I2 by applying KVL to the loop 1, we'll be getting the equation as 14 I1 minus 8 I2 equal to 0. By the same way, if you apply the same current with the, we need to calculate the same through the loop 2, we'll be getting I2 as 28, and 14 I1 minus, will be getting I2 as 28 amperes. We know that I2 has 28 amperes. So basically, we need to directly substitute the I2 in the first equation, which is 14 I1 minus 8 I2 equal to 0. If you substitute 14 I2 in the 14 I1 and minus 8 I2 equal to 0, we'll be getting 14 I1 minus 8 into 28 equal to 0. I1 will be getting as 16 amperes. So now the 8 ohm resistor branch is common in both loops. So 8 ohms resistor is common in both the loops. So we need to find the resultant current IL2. So resultant current will be getting, if you subtract I1 and I2, will be getting a resultant current, which is IL2. So I1 we got as 16 and I2 we got as 28. So basically we'll be getting resultant current, which is IL2, will be getting minus 12 amperes. So here you need to consider one another thing. So this is very important. Uh, Here we will be getting that the direction of current is very important. So here we'll be getting as it is at minus sign. So the current which is passing through it will be in the opposite direction, which is very important. Listen carefully. So here we got as minus sign. So the current passing through the direction will be in the opposite direction. Okay. So now basically we got IL1 and IL2. We need to find equivalent, we need to find total current. So by adding both, we'll be getting total current. So IL1 and IL2, IL1 we got 2 amperes and IL2 we got minus 12 amperes, minus 12 amperes. So we'll be getting total current IL as minus 10 amperes. So here also we got minus sign. So the current passing through will be in the opposite direction. Which direction? Opposite direction. So the current passes through the 8 ohm resistor is 10 amperes and it is in the opposite direction. So this is all. This is the solution for the third question. So that's all for today. Thank you, everyone. Thank you. This is my presentation. Thank you.